Today's point is diode as a rectifier. So here rectifier is one application of PN junction diode. Means in rectifier circuits PN junction diodes are required. First we should know what is an rectifier. So rectifier is a circuit or device which convert AC signal into pulsating DC signal. So for conversion of AC signal into DC signal, rectifier circuit is used. Here pulsating DC is not a pure DC signal. This pulsating DC is further converted into pure DC signal by using filter and regulator circuits. So here this DC signal is important because most of the electronic component or electronic devices requires DC signal, and this rectifier circuit is used or it is required in regulated DC power supplies or in DC power supplies. So this is initial step. This rectification is initial step to generate pure DC signal. First we will see the types of rectifier. There are main two types of rectifier. First is half wave rectifier and second is full wave rectifier. Half wave rectifier, in short HWR, and full wave rectifier, in short FWR. This full wave rectifier again has two subtypes: center tap full wave rectifier and bridge rectifier. So these are types of rectifier, main two types, half wave rectifier and full wave rectifier. Again full wave rectifier has two subtypes: center tapped full wave rectifier and bridge rectifier. Here this half wave rectifier requires only one diode. One diode is sufficient to design this half wave rectifier circuit. Center tapped full wave rectifier requires two diodes. Bridge rectifier requires 4 diodes. Then we will see the difference between these rectifiers one by one, starting with this first rectifier, that is half wave rectifier. So first rectifier is half wave rectifier circuit. Initially consider the circuit of this half wave rectifier. So see here with this circuit, diode is shown here. D means the diode. Consider 2 points, point A and point B. Here this one is single phase AC supply. Generally the voltage of this single phase AC supply is 230 volt and frequency is 50 hertz. Means AC signal is considered as a input, and we know AC signal has sinusoidal type of shape, means this type of shape. This one is AC signal. This AC signal is given to primary of the step down transformer. This is step down transformer, and transformer consists of the two windings, primary winding and the secondary winding. To this primary winding, this single phase AC supply is given. Then to secondary, this diode and the load resistance RL is connected. Across this load we get output signal. Let that output signal is EL. Is the output signal or load voltage. Also consider the secondary voltage or secondary signal, ES. ES is secondary voltage. So this is complete circuit of this half wave rectifier, which requires only one diode. Here step down transformer is used because this step down transformer reduces the voltage. Here this 230 volt is reduced by this step down transformer. Here step down transformer is selected because the DC voltage which is required for electronic component or device is very less. So 230 volt is very high voltage. So this much voltage is not required. So initially that voltage is reduced as per the requirement. Means these step down transformers are available in different ratings and different output voltage range, like 6 volt, 9 volt, 12 volt. So as per requirement we have to select this step down transformer. Here this transformer only reduces the voltage, means input to the transformer is AC and output of this transformer is also AC. Only difference is there is change in the amplitude or voltage. So this is all about the circuit of this half wave rectifier. Then we explain operation of this half wave rectifier. First consider the positive half cycle of the input. Is first operation of half wave rectifier during positive half cycle of input. This initially consider positive half cycle of the input, because here this AC signal consists of alternate positive and negative half cycle. When positive half cycle is completed, negative half cycle start. When negative half cycle is completed, then positive half cycle is start. So initially consider the positive half cycle of the input. So when input is positive half cycle, then voltage induced in secondary such that point A is positive and point B is negative. This positive half cycle is produced in the secondary of this transformer. Therefore, the polarities of these 2 points, point A is positive and point B is negative. Here anode is connected to the point A. Therefore, this anode terminal is now positive. Cathode is connected to point B and point B is negative. Therefore, this cathode terminal is negative. We know when anode of diode is positive and cathode is negative, that diode is forward biased. Here this PN junction diode is forward biased. In forward bias condition, current flows through the diode because resistance, forward resistance of diode is minimum and ideally it is 0. So this diode offers minimum resistance. Since resistance is minimum, current flows through the diode. So current flows through diode and that current goes through the load resistance. Let current through load is IL. So this load current flows IL through the load resistance. When load current flows, then output voltage is available. This output voltage EL depends on magnitude of the current and value of the resistance, that is IL into IL. That product of this current and resistance gives this voltage, load voltage, and this output voltage depends on magnitude of the current. So through waveforms we will see the effect of the input signal on output. So first consider input signal. Input signal, that is ES, secondary voltage. That secondary signal is AC. Consider second waveform is of load current IL and third waveform is of load voltage EL with respect to time. So initially we have considered the positive half cycle of the input. So in positive half cycle, current flows through the PN junction diode because we can replace this PN junction diode by closed switch. In this way we can replace that diode by closed switch. When switch is closed, current flows through that switch. So here diode works as a closed switch. So in positive half cycle, diode is replaced by closed switch, then current starts from this point A, that is positive point. That current goes through this diode, then through load resistance, then reach to point B and through the winding. So loop is completed by the current. That load current completes the loop. Here that magnitude of current depends on magnitude of the input signal. With increase in input signal magnitude, current increases. When input signal magnitude decreases, current also decreases. So shape of this current is similar to the input signal. Input is positive, therefore this current waveform is also positive. Then output voltage depends on this load current. So when load current increases, output voltage increases. When load current decreases, output voltage, that is load voltage, also decreases. So we get positive half cycle at output when input is positive half cycle, because diode D is on, diode is in on state, diode is on, therefore we have replaced that diode by the closed switch. So we get this type of signal at the output in positive half cycle of the input. Second time, consider the negative half cycle of the input, means operation during negative half cycle of the input. So after completion of positive half cycle, negative half cycle starts. Therefore negative cycle produced in secondary. So polarities of these 2 points gets changed. Point A becomes negative and point B is positive, because negative half cycle is produced in secondary, therefore polarities are reversed. So again consider the diode. If we consider diode, anode terminal of this diode is negative. Here anode is now negative because anode connected to the point A and point A is negative. Cathode connected to the point B and B is positive, therefore cathode terminal is positive. We know when anode is negative and cathode is positive, PN junction diode is reverse biased. Means here this PN junction diode is reverse biased, and in reverse bias condition PN junction diode offers very high resistance. Ideally it is infinite, means very high value. Because of very high resistance, current through this PN junction diode is equal to 0. No current flows through the PN junction diode. Means we can replace this diode by open switch. Here replace that diode by open switch. So diode works as a open switch in reverse bias condition. Since these 2 points are open, so current is equal to 0. No current flows through the circuit. Therefore load current is 0. This load current is equal to 0. Since load current is 0, output voltage is equal to 0. So through the waveform we can see during negative half cycle, diode D is reverse biased, therefore diode is in off state. Diode is in off state. Therefore current through diode and the load resistance is 0. So current is equal to 0. Since load current is 0, that output voltage is also 0. So in negative half cycle, output is 0. Then after completion of this negative half cycle, again positive half cycle start. Polarities again reversed. Diode is on in this positive half cycle. Again diode is on. Diode is on. Load current flows and therefore output voltage is available. So we get output only during positive half cycles, and in negative half cycle output is 0 in case of half wave rectifier. So here this rectifier is called half wave rectifier because it rectifies only half of the input AC signal, means only half cycle of input AC signal is rectified. This output is available only during positive half cycle, and in negative half cycle is output 0. Therefore, this rectifier is called half wave rectifier. So this is all about operation or working of this half wave rectifier. Now this rectifier has some advantages. First advantage is this rectifier requires only one diode, means need of only one diode. Advantages are, first is need of only one diode. Only one diode is required in this circuit. Second advantage is this half wave rectifier circuit is simple to design. Second advantage is simple to design. This circuit is very simple to design. Is very less number of components are required. Only one diode, one transformer, and one load resistance. So simple circuit. The third advantage is no need of center tap transformer. Means here this normal transformer is used. That other special type of transformer, which is center tap transformer, is not required here. So these are some advantages of this half wave rectifier. Then this half wave rectifier has drawbacks. The first drawback is maximum theoretical efficiency is very less. The first disadvantage is efficiency, maximum theoretical efficiency is very less, only 40.6%. This maximum efficiency with this half wave rectifier is only 40.6%. This efficiency value should be as high as possible. Then here the ripple factor, second disadvantage is ripple factor is high, that is 1.21. This ripple factor value should be as low as possible. This ripple factor is very high. This is second drawback of this rectifier. Then third drawback is the transformer utilization factor is very low. Is TUF. The third drawback is TUF, means transformer utilization factor is very less. Means here this transformer is not used effectively or efficiently, because only during positive half cycle we get output, and in negative half cycle output remains 0. Since these drawbacks, means efficiency is less, means less amount of AC power is converted into DC, because here to this rectifier input is AC power and output is DC power, and this efficiency value is less. Therefore, this rectifier is not used in DC power supplies. But the remaining rectifiers, center tap and bridge rectifiers, are used in DC power supplies to convert AC signal into pulsating DC. So in next lecture we will see the remaining two rectifiers in detail.